related to Canvas and stuff, so teaching online or using Canvas. So I'm going to go to that Monday, Tuesday. So this class won't meet, and maybe some of your other classes won't meet. And then that leaves, let's see, so that's Monday. So that leaves the Wednesday, Friday of that week, and then the Monday lecture. And then we have our, what are we going to cover? This is kind of what we're going to cover. We still need to, today I want to do part 5, so I'm kind of going out of order. I want to knock out chemical reactions. Then we're going to go back and pick up mixtures and moles and molar mass. And of course, Thursday of next week, we're going to do another lab. We're going to do another chemistry lab. And then we're still on schedule for what I gave you the first part of the semester. So April 4th, it'd be your unit exam in your homework chemistry. And remember, for your unit exam, you can have that periodic table that some of you guys have been dressing up. If you don't want that periodic table for some reason, you can just use a blank piece of paper front and back. So, any questions about all that? Okay, cool. Oh, and then, like usual, then the Friday following your test, we'll go ahead and kick off a new unit, and we're going to go back and do physics. I recently have agreed to be on 2 search committees because I'm excited about both these positions. So what that means for my students is that they're in April sometime. I might need to meet with candidates, so interview and such. So I'll keep you posted. When I know it, I'll let you know. And the other thing that means, unfortunately, or whatever, is I'm probably going to feel rushed to get all the lecture in that I think we probably need to get in for this class. So along those lines, I tell all my students, if it feels like I'm talking 100 miles an hour, feel free to say, Mrs. Snipes, you're talking 100 miles an hour, can you slow it down? Or ask me a question or something like that. All right, so here is kind of what along the lines you guys did in lab. Nice job in lab. It's funny, the number of years I've taken chemistry courses and worked in a lab. I actually worked at the Middletown Army Ammunition, Iowa Army Ammunition Lab as both a chemist and then as a supervisor of sorts. So what was I going to say? Oh, but it's interesting to see when you're kind of first like measuring up stuff and putting stuff together, kind of what that feels like or what that looks like. So part of the goal of this class is just to kind of expose you to some of the various labs that you might have in these different types of physical sciences. So good job, it is fun. So a chemical reaction, the word is new substances there. Yesterday we had a lot of different color changes, mostly just I think color changes. One case it went from a clear to a cloudy. That cloudy liquid means that you actually got some sort of solid forming, so that's new if it's a solid, from being all liquids to having at least one solid. So if you get new substances formed, then you know a chemical reaction has occurred. And like if I hold my hands up here, this would be what I start with, and this would be what I end with, okay? So start with, end with. Okay, we call these actually, the word is electrons up there. You're like, well, why do you get something new? Why would that be? And actually it has to do with kind of the atoms rearranging and kind of ending up with a happier or more favorable energy. That's kind of why it goes, is it wants to go generally energy downhill. So that's why it rearranges and we get new compounds are formed. But like this says up here, and we're going to kind of talk about this today, the center of the atoms don't change, but electrons can kind of rearrange themselves so we get different products, different stuff over here. So the fact that the nuclei of the fact that the nuclei stay the same, actually we're going to count numbers of atoms. So if we have 12 hydrogen atoms over here, we have to have 12 hydrogen atoms over here. If we have 6 iron atoms over here, we have to have 6 iron atoms over here. So that's what it says, that the centers of the atoms stay the same, but they might be connected to different things. So we did a lot of this on the board. You guys had 5 and then maybe even a 6th chemical reaction that you guys went through. And so I told you yesterday, I'm not a wordy person. So give me a chemical equation anytime, and I'll be like, oh, that's so much better. And sometimes we can kind of beef up, this is a chemical equation, we can kind of beef it up, add to it to tell a lot of information in just a concise way. So I'm like, that I can appreciate. So we're talking about chemical reactions. Excuse me, we'll be talking about chemical equations that describe a chemical reaction. And so, like this says, by convention, I've been saying we read it from left to right. Now, in chemistry, if you go on into chemistry, you'll find out that actually there are chemical reactions that go both ways. They go from left to right, and they also go from right back to left. But in general, we're going to kind of read them with one reaction arrow, kind of separating what you start with and what you end with. This, I don't know what I haven't thought of too closely what your Unit 3 exam is going to look like, your unit exam over chemistry, but these are great terms to throw on that first page, the second section, you guys, the vocab, those make great vocabulary words. The word is formulas up here. We use chemical formulas just like you saw yesterday to, again, nice and concise. You don't have to be wordy about it. You just write the chemical formula. What you start with, what you end with. My little brain can handle that. I'm going to play you a video here in a minute. It's about 12 minutes long or so. But you're like, well, how do you know new substances are formed? That's the key indicator that you've had a chemical reaction occur. Well, one is you could have a color change. One is you could have a precipitate. This is kind of the cloudiness I was talking about. What this is saying is I have clear here and I have clear here, but when they mix, I have cloudiness. So that means new stuff is formed. You could have a gas form. When we did, you can have gas form. You can have heat released or heat absorbed. And this is actually light emitted or light absorbed. So let's take a look at this video of things we aren't going to get to with regard to, they have, you start with reactants on the left, and which end with products on the right. And so I want to focus on the, I guess I should say equations. Equations are pretty basic. They have that arrow between the reactants and the products, a chemical equation. But there are two types, broadly speaking, two types of chemical equations. There are what we call the unbalanced. The word is unbalanced. So then I've been standing up here and I say if you start with 6 irons, you have to end with 6 irons. If you start with 12 hydrogen, you have to end with 12 hydrogens. That would be balanced. But it doesn't have to be balanced. If you don't balance it, that's fine. And we're going to talk about balancing it. If you don't balance it, that's fine because you still know the reactants and the products. Okay, you might know, we'll talk a little bit about this actually yesterday when I put an S next to it, it meant solid. When I put an L next to something, that meant liquid. I put a G next to something, that meant a gas. So it can show that. For one of your experiments yesterday, I don't know if you noticed, that was one where you heated it up. I actually put on the reaction arrow, I put the word heat. So you can also say like that if there's any special reacting conditions. The other type of chemical equation would be one that is balanced. Okay, so a balanced one goes back to you have the same number of atoms of each type of element on both sides of the reaction arrow. We'll talk about that. So not only the balanced equation, think of the balanced chemical equation just like taking it up a notch. So it gives you all the, we call qualitative information. Qualitative is the opposite of quantitative. They both start with the letter Q, but qualitative just means general stuff. And quantitative means like number stuff. Okay? So it gives you all the qualitative stuff and it gives you relative amounts or number stuff. Okay. So I mentioned these, so an S would be solid, an L would be liquid, a G would be gas. And I don't know if yesterday we had any AQs. An AQ probably had them, I just didn't, maybe, I don't know. So for instance, I think it was, this was your 250 ml beaker. It was blue. And I'm pretty sure it was blue to the presence of copper 2 nitrate. So Cu NO3, 2 of those. So aqueous means actually what really happened. I'll go and I'll show you in the form of an equation. What happened is in the presence of water, I'll put water over here, this actually broke down into copper plus 2, I'll put AQ because it's running around in water, and then I'm going to put 2 NO3s, and they actually, this is, the NO3 is a nitrate, so we'll get 2 of those running around in AQ water. So that's what aqueous means. It means that you have a medium that's water. All right. So again, yesterday I put the word heat over the reaction, one of the steps where you guys had to heat it up with your Bunsen burners, just as nice, concise way of telling a person looking at that reaction represented by that equation what you need to do. Sometimes there's a specific temperature, you could put that over the reaction arrow. If a catalyst is needed, if it needs to be dark, if it needs light. So again, nice and concise. I like that. So I want to spend a little bit of time now talking about the what's called balancing equations, or seeing if an equation is balanced. So the word is in front of the chemical formula. Those are called stoichiometric coefficients. Stoichiometric coefficients. That would be another good vocab word. So let's see what I mean by how this works. Oh, I think we'll go ahead, and I hope it's not too cheesy, but I have another video I want you to look at that talks about that balancing aspect of equations. Let's see, just like they did. Oh, sorry, did you need the word number here? Same number. So for the first chemical reaction, we have P4. Notice I'm bringing that subscript 4 with the phosphorus. That's a reactant. We have Cl2. I'm not worried about, I put a 6 here, but I'm not worried about that saying what the reactant is. The 6 goes with how many we have. And then over on the product side, we have PCl3, which is what is formed. How many do we have? We have 4. So we can kind of confirm that that's balanced, and I have a little tally thing, kind of like you saw in the video, where I like put a kind of a brick wall there on the reaction arrow, and on both sides I put P is equal to Cl is equal to, and I put P is equal to Cl is equal to. So the fact that, by the way, I don't have a number in front of the P4. I don't have a number for my stoichiometric coefficient, so it's implied it's just 1. So if I have 1 P4, then I have 4 phosphorus atoms. And if I have 6 Cl2s, do you buy this? That must mean I have 12 Cl atoms. Over here on the product side, I have 4 PCl3s, so that means I have 4 phosphoruses. And it's kind of like math or multiplication. I have 4 times 3 or 12 Cls. And that's just kind of like what we saw in the video. That's what makes it balanced. So the stoichiometric coefficients for the next set look like this. Oops, sorry. So there should be nothing in front of the CH4. That means 1. There should be a 2 in front of the O2. And nothing in front of the CO2, that means 1, and a 2 in front of the H2O. And then the last one looks like this, where there should be a 1 in front of the Al2SO4 just a 1 there, a 6 in front of the NaOH, a 2 in front of the AlOH3, and a 3 in front of the Na2SO4. Okay, so those are stoichiometric coefficients to balance it. Do you guys have this slide too? Sure, I can check. No, you don't have a speed one. I don't see it anyway. I don't know why I put this one in. It's 2 slides. Oh, is this the same as the last one? No, I think I'll just go ahead and skip the next couple of slides for me. Oh yeah, so this one, duh. You're like, because you did not answer that. So this is the second one there, actually, on the page that you do have. And let's go ahead and confirm that we have the same number of atoms of all of the elements on both sides of the reaction arrow. So usually you have more room than I had a minute ago. So I'm going to line up the carbons equals, the hydrogens equals, the oxygens equals. Carbon, hydrogen, oxygen. I'm going to go ahead and see if I can wake you guys up. I'm going to go around the room. Starting with you, David, help me out. Here on the reactant side, how many carbons do I have if that's a 1 in front of the CH4? 1. Yep. Feels like a trick question. Yep. We'll go back to you, Melissa. So again, so just with the formula CH4, because there's no hydrogens here, how many hydrogens do I have? 4. Yep, you got it. So Kaylee, I don't know if I'm getting you guys' name mixed up. So Kaylee, how many oxygens do I have? I have 2 O2s. How many oxygen atoms?
You have 4.
I have 4. Perfect. You guys got it. So over to you, Genesis. How many carbon atoms do I have? What's that?
1.
Just 1. Yep. And then help me out, David. How many hydrogens do I have?
2.
Well,
Or is it
I have 2
4?
H2Os. I do have 4. Yep, that makes it 4. You got it. And then Melissa, how many oxygens do I have? But you have to add the oxygens here and the oxygens here.
So 4.
4. Yep, I have 2 here and I have 2 here. So I got 4. You got it. So when we talk about, like we saw in the cheesy video, this means that it's balanced. And I'm going to skip this one. Okay. So I think I have a picture here that goes with the equation. So showing the CH4 molecule, the O2 molecule, you know, the CO2 molecule and the H2O molecule. The red represent oxygens, the black is a carbon, and the white are hydrogens. So we could give this to a youngster and they could recognize that with regard to the red ones, we're not balanced, are we? Actually, with regard to the white ones, we aren't balanced. So on the next slide, you're going to see how we can balance this. This is a visual showing it's not balanced. So if instead of 1 O2, if we go with 2 O2s, and instead of 1 H2O, if we go with 2 H2Os, then we have the same number of black atoms, same number of white atoms, the same number of red atoms, which of course the color represents different elements. So it is balanced. So let's just make sure we're all on the same page here. So I've got 4, or I can't remember who did I leave off there. Oh no, Melissa, or Drat, Kaylee, oh my gosh. So Kaylee, what's the stoichiometric coefficient of the CH4? It's the number before it. And it represents, stoichiometric coefficient represents how many of those we need. It is 1. Yep, stoichiometric coefficient is 1. So Genesis, what's the stoichiometric coefficient of the O2? 2. It is 2. David, the CO2? 1. And Melissa, the H2O? What's the stoichiometric coefficient?
2.
It is 2. Yeah, you got it. So like the video said, and the little evil guy came in and was going to break the law of the universe, which is an important law, the conservation of matter. So the word is mass up here. Mass has to be conserved. The word is created or destroyed.
Can you go back to that one?
I sure can. Okay, so I'm going to talk you through balancing one, and I think I didn't double check, but it looks like the homework I'm hoping to send home with you, you'll get to do some of this on your own. But first off, you cannot change any of the formulas. And by that, I mean, if you change a subscript, you would be changing the formula. So, for instance, in the one we saw in the video, he was taking H2 and N2, and he was going to form NH3. Okay, you can't just go, well, I'm going to change this to 3, and I'm going to change this to a 1. You can't do that. That's playing God. But what we can do, and what we did see him do to balance it, was to go ahead, what they ended up doing, putting, let's see, it was a 2 here, and then to balance it, and usually I put a little squiggle there, showing that's my stoichiometric coefficient, and they had to put, goodness, he put a 3 here to get it balanced. That's what we saw him do. Okay, so you can and you should have to change the stoichiometric coefficients. So the word is number. You can make changes to that big number to, I call it the big number to the, I get my left and right's mixed up, the big number to the left of the reactant or product. That's awesome. Recognizing, just like you've hopefully kind of got a sense of, that stoichiometric coefficient applies to all atoms here because it's how many of those groups you have. So when we put a 2 here, that meant we had 2 nitrogens and 6 hydrogens. Yeah. So here's the one I kind of want to do together. Let me grab my... Okay, so I'm going to put a brick wall. And actually my daughter taught me this, this way, is how she was taught to do it in high school. So I put, and I think I'll put it above because I don't know what's below. I'm going to put Fe is equal to, and I'm going to put H is equal to, I'm going to put O is equal to. Fe is equal to, H is equal to, O is equal to. And we're going to go around the room. So with coefficients of 1 across the board, and I'll warn you, it's not balanced, but you have to write down what you're starting out with. So David, help me out. How many Fe's do I have on the reactant side, on this side?
Left side?
Yep.
1.
I have 1. Melissa, how many hydrogens?
2.
2. Kaylee, how many oxygens? 1. Genesis? Now on the product side, over here on the right, how many Fe's do I have? 3. David, how many hydrogens do I have? 2. Perfect. And then Melissa, how many oxygens do I have? 4. So you off the bat see that we have an issue here. And what we can do is we can, okay, so then back to you, Kaylee. How can we fix, I'm going to start with actually the most complicated, so let's fix our oxygens first. We have 1 oxygen over here, 4 oxygens over here. So, Kaylee, how can I fix it? Yep, I put a 4 in front of the H2O. And working at using this method, I'm going to put a 4 there, and then I have to update. So, I think we're to you, Genesis, maybe. If I put a 4 in front of the H2O, I need to update my hydrogens. How many hydrogens do I have? If I put a 4 in front of the H2O, not 6, because I have 4 of these.
8.
I have 8, yep. I have 8. So I'm going to update the 2 to an 8. And then, David, how many oxygens do I have? Now, if I put a 4 in front of my H2O. I have 4, yep. Very good. I'm going to update that to a 4. So my oxygens look great. My irons and my hydrogens are messed up. And we're not going to get through the other one. This is the last. Yeah. I can't remember. I didn't have a. We're going to have to wait for Wednesday because I don't want to rush through this. We're going to pick up here. So remember all that we talked about today. We'll pick up here on Wednesday. So there's no homework due. A nice long, another long break. Okay? We should be fine though, time-wise.